Welcome to another episode of the Mapscaping Podcast. My name is Daniel and this is a podcast for the geospatial community. My guest on the show today is Paul Ramsey. So Paul's been on the show a couple of times before. I know him as the co-founder of PostGIS, which is a spatial extension for Postgres, for the Postgres database. But beyond that, I think Paul is also a champion for open source geospatial software, open source development in general. And I think if we zoom out a little further and look at the depth and breadth of his contributions to the geospatial world, I think you'll find that Paul's just a really generous person. But I'll let Paul introduce himself in a little more detail in just a second. Before we get started today, I want to tell you that I've started a new project. So if you go to mapscaping.com/jobs, you'll find a job board. It's still in the developmental stages, so I'm still testing things out, but I'd appreciate it if you took the time to check it out. So if you're looking for a job in GIS or geospatial in general, this would be a good place to start. Okay, without further ado, here is my conversation with Paul Ramsey about putting rasters in a database. Why you shouldn't, why you should, and how you can if you want to. Hi Paul, welcome back to the podcast. You've been on a few times before and it's awesome to have you back. Today we're talking about rasters and databases. We're going to talk about why you shouldn't put them in there and perhaps why you should. But before we get into all that great stuff, I know you as the co-founder of PostGIS, which is a spatial extension for Postgres SQL. But if you had to introduce yourself to people that maybe hadn't heard you before on this podcast, how would you do that?
I am a database programmer of a certain age. I think that's it. It's hard because I'm not sure how many characters I'm using. Maybe I could get a second sentence in there. The databases I work on are for maps and locations.
Right. So I think people need a little bit of context there. I asked Paul to introduce himself in a tweet, and this is what he's trying to do.
Yeah. So I don't know if that works. It's hard to squeeze it all down. I hope that an audience of geospatial people would know about PostGIS, but they might not these days. And of course, a lay listener maybe wouldn't know about it at all. But
my guess is a lay listener will not be listening to this podcast. And will definitely not be listening to this podcast about how to put rasters into a database. At least that's my guess.
They would be smarter than that, yes.
Yes. Okay, so brilliant introduction. Thank you very much. There'll be links in the show notes to the previous episodes that you've been on, and I highly recommend people check those out. So the promise is a conversation about rasters and databases. And I'd like to start by maybe listing some of the reasons why you shouldn't put rasters in a database. And then perhaps we could explain, well, if we haven't managed to convince people that this is a bad idea, maybe we should give them a recipe for what they can do, how they can put rasters in a database. So let's start there. Why shouldn't I put rasters in my database?
You skipped a step, Daniel. Oh. Step one is to say, hey, I have a database. I love having a database. Databases are great for large-scale data, right? And they make handling big data really fast, right?
This is true, yeah.
And my rasters are big, and I like them to come back really fast. So surely the correct thing to do is to put my rasters in my database. Am I not right?
You're right. Brilliant. Great idea.
Yeah. I mean, that's how the conversation starts.
Okay, great. Sorry. Apologies.
Yeah. And then we say, oh, for the love of God, no, please don't. Please don't put your rasters in the database. Because your rasters are very, very large. And the larger your database gets, the harder it gets to manage. People with what they consider very large operational databases in the non-spatial world will say something like, my database is 20 gigabytes. Can you handle that? And, I work at a database company and we kind of laugh and say, how big servers get these days, right? That whole database will fit in memory. But that's like an example of like a large production database in the non-spatial world. People with rasters are going to walk in with a couple terabytes worth of data just for a start. And having a couple terabytes in your data just changes the operational characteristics of it a lot around things like, how do I back that up? And when I back it up, how do I deal with the 2 terabytes of backup data I've now created? Like, it's hard enough to deal with 2 terabytes just sitting there, and now you have multiple copies of it lying around. Which gets you to like the second thing, which is databases are built not just for like handling big data, but for handling dynamic data. The contractual guarantee you get when you put your data in the database is like, I will never lose it. Doesn't matter what you do. You can walk up to a running operational database and rip the power cord out of the wall and then plug it back in, and it'll come back up and say, I'm ready for you. Come on, give me some more data. Because they're built to be fault tolerant. They're built to handle things like inconsistencies and doing rollbacks, and all that stuff makes a lot of sense if you're running, a system where the data is changing all the time. Raster data doesn't change. I mean, it gets added to. Very rarely do you go in and say, I want to edit these pixels and change this value from this to that. You're making it hard to manage your database. You're not really getting a lot of use out of one of the main strengths of your database. It's not going to be any faster. It's worth pointing out. One of the things that's great about a standard database with respect to something like piles of text or randomly ordered values of numeric data is that you can put indexes on that data and then get really fast access, random access into the parts you care about. Raster data is intrinsically already indexed. It's a great big grid. So you can get the parts out of it you want extremely fast just by leaving it in the format you got it in. Putting in a database doesn't give you leverage with respect to speed. So in terms of scale, it makes your database harder. In terms of speed, it's not any faster. In terms of getting the most out of what a database is, it doesn't really. So that's why it's a bad idea to put your rasters in a database.
It sounds to me like you could be a great spokesman for cloud-native raster formats.
Yes. Cloud-native raster formats take the fact that rasters tend to already put their data into very useful, easy-to-access structures, and to kind of ramp that up to 10 by being very, very careful to make sure that you're not having anything inefficient about how you store the data. I'm going to say, quote-unquote, on disk, but in the cloud. All data files are like linear hunts of bytes. Formats just tell you where the bytes are. Cloud native deliberately try to put the bytes in places that it's convenient to quickly access little pieces of the file so you don't have to download 2 terabytes of image to get the 500K you actually want to look at.
And I really want to mention cloud native raster formats here in the conversation because I want to bring them up again later on. Okay, so I'm convinced it's a bad idea.
Yeah.
There's still a part of me that wants to try anyway.
Mm-hmm.
Like, why would I want to try, do you think, if you had to guess?
There are some legitimate reasons for wanting to have raster in your database, but they kind of come back to why would you want to have raster at all? Rasters have a couple, they have, the primary thing that differentiates, say, a raster from a vector is that rasters are full coverages and they have very, very high data density. They're great for representing surface information, continuous measurements across a large area. So, I mean, the classic non-visual raster is an elevation model. Every pixel is slightly different from the pixels beside it, but you can't really throw away the information without throwing away chunks of the data. Like you can turn a visual elevation model into contours, but you've thrown away some data in doing that. So you've got some kind of continuous surface, and it tells you something about the world, whether it's telling you something about rainfall or elevation or slope or whatever. You probably also, if you're a geospatial person, have some vectors that are of interest to you. And maybe there's some aspect of the rasters that you would like to interrogate with respect to the vectors. For every address point, can you tell me how high it is? That will very quickly tell me whether it's going to flood given these current flood conditions. So there's this whole category of analytical questions you might want to ask of a surface that involve raster vector combinations. And if you don't have the data inside the database, you have to write some sort of script, some sort of routine to do that integration for you. If your database is capable of holding rasters and vectors at the same time, it becomes possible to answer those questions using the same SQL tools as you use for your standard vector questions. And thus, all the other third-party, anything you can then attach to the database can do raster vector GIS analytics, which is great. Now you're a more powerful GIS operator.
Okay, so as luck would have it, I am a geospatial person. I do have access to a database that has the capabilities of storing raster and vector.
Mm-hmm.
I have these rasters, which represent surfaces that don't change very often, but I have a lot of vectors that change on a regular basis, and I want to add information from these surfaces to my vectors. So maybe for someone like me, this makes sense. I have all of my data in one database. I can access it through SQL. It's very close to the machine. There's a simple development path, and I can use a language that I'm comfortable with, SQL. None of this is true, by the way. But if it was, how would I go about getting my rasters into the database?
Okay, so now we're getting moving away from the platonic raster database, of which I should point out, more than one. We're going to be talking about PostGIS because that's what I know and that's what I do. But Oracle Spatial actually includes a raster module as well, which has some facility for doing this kind of stuff. Although I got to say, they tended to build their product more with an eye to people who just want to stuff the data in and get the data out. Fewer built into the database analytical routines, but they do have some. So we're getting into the PostGIS world. You're going to load your data into the database. You actually have two options to get your data into the database. You can literally put your data in the database. That is to say, every pixel that you own will reside inside the database. And we call these in-DB rasters. You can also do a different thing, which is to load just little pointers into the database, which say, over here in this file, there's some pixels you might want to look at. We call those out-DB rasters. Regardless of whether you're loading in-DB or out-DB rasters into PostGIS, you will be using some kind of loading tool. There's really two options. The one that ships with PostGIS itself, which is a tool called Raster to PGSQL, does what you would expect. It reads a whole pile of different raster formats, allows you to set some flags which determine how the data will be loaded into the database, and then generates a SQL file which you can then pipe directly into your database.
So I just want to make sure I understand that this tool, this raster to PGSQL. So this can do both. So it can either store my rasters as actual pixels in the database. I'm assuming it'll take care of all of the tiling, that kind of thing. Or I can tell it, well, actually store it as pointers.
Yeah.
In which case, I guess there's some tiling that takes place as well. But then those tiles are being stored as individual pointers to external files somewhere.
Correct. Yeah. So OutDB, you still end up tiling the space of the input raster, because the input rasters can be quite large. Well, they're always quite large, 1,000 by 1,000, 10,000 by 10,000. They're quite big files. The way you have to deal with a really big file like that in a database is chop it into much smaller pieces. And ideally, in the PostGIS world, you want to chop them into pieces such that they're, well, for in-DB, such that they're smaller than the page size. And the page size is quite small. It's 8 kilobytes, which means that even for a single band raster, you're looking at things not much bigger than 32 by 32 or 64 by 64 pixels. These are just options you can tweak up and down using raster to PGSQL. The levels of tiling do depend on whether you're doing in-DB or out-DB raster work. In the out-DB case, your binding constraint for performance is not going to be getting tiny little tiles of data off the disk. It's going to be accessing larger chunks of tiles from external file sources. What you're really going to want then is a tile size which matches kind of your expected query size. So you don't end up doing a whole bunch of external fetches to answer standard queries. So you can get it down to like 1 or 2 external fetches per query.
Okay, so I want to start with in-DB rasters. So you talked about this page size and the limits there. I want to know a little bit how pixel depth might affect that and the number of bands a raster can hold, and maybe any constraints around the formats that we can feed into our PostGIS database.
So raster PGSQL is multi-format on the input and one format on the output. So it'll read any format that the GDAL library will read. It's linked to GDAL. Incidentally, like I said, there were two utilities you could use to load rasters into PostGIS. The other one is GDAL. so there's that. But I generally use raster to PGSQL because it's kind of a purpose-built tool. So it'll read any GDAL format at the input, and it will write just the PostGIS raster format on the output. PostGIS raster format is as flexible as it needs to be to handle pretty much any kind of raster input. So how many bands can a PostGIS raster have? How many bands do you have? There's no limit to the number of bands you can put in terms of pixel depth, everything from a bit to 8 bytes, and also floats, both 32 and 64-bit floats. So really any pixel depth you would expect to have, both signed and unsigned for integral values. So it can represent really any input. The more bands you have, obviously the more space each pixel will take. And then if you're trying to fit into the 8K page size limit, then the more bands you have, the smaller your tiles are going to be. So there's limits there, but there's nothing that stops you from having a tile which is larger than the page size. It's just like a preferential thing because you get slightly better performance when you're not exceeding the page size. And this is one of the things I dislike about rasters in the database is that you get very quickly into talking about the actual implementation details of the database itself, which is a bad sign. It's like a bad smell. For a database app, the whole point of a database app is to abstract you away from the hardware, so you really shouldn't care ever. But the fact of the matter is, if you store data which is larger than the page size, the database has no choice but to chop it into things which are smaller than the page size and hide from you the fact that it did it by putting them into a side table and quietly reconstructing them whenever you ask for them, which, as you can imagine, has a bit of a performance overhead.
Yeah, yeah. All of that makes a lot of sense. And also, I think you answered a lot of my questions as soon as you said the other tool you can use to load data into the into this database is GDAL. I'm like, oh, okay. Well, that answers a lot of questions about what formats it can handle and that kind of thing. So, yeah. One thing we haven't mentioned is something called PostGIS Raster. It's an extension, I believe.
Yeah, so up to PostGIS 3, which at this point is actually quite a ways away, like 5 years ago, 4 to 5 years ago, depending on when this is being listened to. Up until then, if you wanted to say installed, but rather enabled the PostGIS extension, you would type create extension PostGIS, and you would get everything. You would get the vector side and the raster side at the same time. Around 3, we kind of realized that most of our users were using vector and didn't necessarily want to have the dependency of the raster module lying around every time they use PostGIS. So we broke it out into its own module. So if you type create extension PostGIS now with any version 3 or higher of PostGIS, you get the vector side. And if you want to add the raster side, you go create extension PostGIS underbar raster. And that just loads the other module and the rest of all of the raster functions that go with it.
Okay, so you've done a brilliant job of walking us through this in DB rasters, what it means, how we get data in there, how it's stored in the database, the tools we can use, even the extension that we need to enable. Let's talk a little bit about out DB rasters now. Pointers to external pixels. What does that mean?
So we still have tiles. We still, at load time, look at the original file, figure out where it is, figure out what its geometry is. And by geometry, I just mean its width and height, its skewness. But at load time, we, instead of loading a little chip with all the pixels, we load a little chip. It's still got bounds, so it's got a little location. It still has information about things like the bit depth and number of bands of the underlying data. But instead of then going and saying, here's all the pixels, it says, and you can access them over here. And the over here part, actually, if you go into the source code, and there's also functions you can use to interrogate the little tiles and find out what's inside them. If you do those, you'll find that the over here thing is literally just a GDAL connection string, which when you start thinking about the things that GDAL can do in terms of file access, kind of makes your head explode. Because it's not just, well, it can just be like a file on a file system, just a simple path, but it can also be any of the ways that GDAL accesses data, which includes things like an S3 bucket location or an Azure blob URL or just a standard URL on somebody's web server, as long as it has relatively modern HTTP service on it. It's incredibly, it can do even crazier things like pull data out of zip files, but obviously for performance reasons, that's a terrible idea. But in terms of being able to access remote data, it sort of opens up this whole extra way of thinking about where you might want to store your data, how you might want to access it, what you can do when both your database and your geospatial data are sitting in the same cloud. Being free of file systems gives people a lot of system design flexibility.
I think this is really interesting, actually. So this idea that I could access cloud-native raster files through my database, essentially, and it almost sounds like you're using GDAL in the background somewhere to build virtual files, pointers to here, go over here, follow this URL and get the data here.
That's exactly what it is. And it comes with like the same big warning label that any virtual files like can or should have, which is if you ask for too much of it, it will get slow because it's not actually local to your computing. It's somewhere else, and usually somewhere else with a fairly high latency. Even when you're sitting inside the same cloud infrastructure, the latency of doing an HTTP access versus the latency of doing a file system block access is a good deal higher. Obviously, way better if your database is in the same cloud as the files. But yeah, it's a totally virtual layer, and it means that the things that you tune for, like we still decompose these big raster files into tiles, but instead of the tuning parameter being what's my database page size, it's, well, I know that all my raster tiles, my cloud optimized geotiffs, if you will, are tiled 256 by 256 because that's the standard cloud optimized geotiff tiling. Maybe you've used something non-standard, but that's the standard. I should also, for efficiency purposes, make my database tiles the same size because it increases the odds that any given fetch will be a single call across the network to the remote cloud TIFF.
Yeah, so help me understand this. So I'm thinking I've got my database, and I know I can use GDAL to load data in there. So I'm thinking I've got some cloud optimized geotiffs somewhere. I point GDAL at them. I use that to interrogate it. I figure out some information about that. I use that to inform my decisions of how I'm going to make these sort of virtual tiles, if you will, in the database in the form of pointers. And once I've done that, I can essentially start doing things with my rasters, so adding elevation data to my road lines or something like that.
That's exactly right. You can take the data in place and just start working with it, quote unquote, in your database, even though the raster data, which is quote unquote in your database, is in fact living somewhere else.
This is amazing. I mean, in this cloud, the cloud native world that we're sort of moving towards, a little bit hesitant to say that we're there now, but moving towards, definitely, it's kind of incredible, right? So I could point this at, I don't know, the Microsoft Planetary Computer. I know they've got a bunch of cloud optimized geotiffs there. You know, they've got that stack interface, interrogate that, find the data I want, update my vectors based on that, and then cut the connection.
Correct.
This is amazing. Can you tell me a little bit about the raster functionality, if you will, in SQL?
Yeah, so it starts with sort of like the raster vector side. So you can take any given vector, be it a point, line, or polygon, and tell it a raster geometry, which is to say, a bounds and a pixel size, and say, rasterize that vector. And it will give you the equivalent in raster space. And vice versa. You can take a categorical raster that has, a given category for, clear cuts, and say, polygonize that category, and it will go and spit out a polygon. So you can go back and forth in that way. And that's useful for doing things like building masks. So you can take housing footprints, rasterize them. Now you have a mask, drop that mask across, say, the elevation model. Now you have some elevation measurements, and then summarize those elevation measurements. Now you have the average elevation underneath the house. So you see, like, all this stuff is like raster vector. The bits come together. Very simple stuff. For any given point, read the raster value off the underlying raster that you have. For more complex features, whether they be polygons or line strings, read from the underlying raster and populate the M or the Z dimension of these vectors. So there's a lot of tooling for like going back and forth, and for reading information off the rasters, which I think is like tooling that will get used most frequently. But the module was built with a great deal of optimism that people would want to do even more advanced raster stuff, like the kind of things you see in full-on raster GIS systems. So there is actually a raster map algebra facility.
Wow.
So you can take rasters and do math on the pixels, double this, add these two rasters together, subtract A from B, or bandwise, subtract this band from that band, or do this math with that band and add them up and spit out a new raster with the result in its band. It's pretty crazy powerful within the constraints of the storage model for the rasters, which is these tiles. And this kind of gets you back to like, there's always this push and pull with the raster module, which I don't feel there is in the vector module, which is complexity of implementation and performance versus the theoretical power of what the system feels like it should provide you. Because when I say you can do map algebra, people think, well, that's great. I've got 100 terabytes of raster here. What I'd like to do is assemble a whole bunch of raster map algebra and have it spit out another 100 terabytes of results over here. And the reality of implementation is that, assuming all the SQL was easy to do, which it's not, assuming that it was, it would still run when you pumped it into the database and hit go on your SQL command. It would run in a single execution thread, which for your 100 terabyte processing is probably not what you want. You were probably envisioning that the database would transparently spread it out across 64 cores or something for you. And that just, except for a few minor edge cases, doesn't usually happen.
Do you think we'll get to that stage, though? When you think about the development of PostGIS and the raster module, is that where you're heading?
No, I don't think it is. And not because we don't want to do it or don't think it would be awesome, but because the architecture of the underlying database is not well suited to do that. You can get a certain amount of parallelism out of your Postgres database, but you can't get 100 wide parallelism out of your Postgres database. And at the end of the day, PostGIS is a creature of Postgres. So we get precisely what the core database provides us. And at this point, this is like up to 4 to 16 wide parallelism, depending on how the query plan happens to fall out. And unfortunately, the way raster query plans happen to fall out doesn't always result in any parallelism at all.
It's interesting because I often think of like raster math, for example, being easy to like embarrassingly parallel.
Oh, it is. But this is, again, getting into this sort of mismatch between the model that the database expects to have and the model that rasters have. Like, it's embarrassingly parallel in raster space because whatever process it is that is working with the rasters knows ahead of time that it's got this huge, perfectly segmented input data set. And that's why you can get tools like GeoTrellis or like Google Earth Engine or like the Microsoft Virtual Earth. Like, they know that they're dealing with rasters and they can, automatically push it out to as wide a possible fan as it can. Whereas the database just knows I've got a row, I've got a row, I've got a row, I've got a row. And it might know as a result of analyzing the logic of the SQL that some rows are independent of others, but it doesn't know the data structure in the same way that a raster native processing framework can and does.
I'm not the developer you are, but that makes a lot of sense to me. I want to ask a question about exporting rasters. So before we talked about how we could put any file type that GDAL could read into our database if we wanted to, and then it would be stored as a single file type within the database. What about when I want to take it out again?
Not quite as flexible, but we do have some of the simpler GDAL formats. So visual formats, you can do an ST as PNG or an ST as JPEG against a Postgres raster, and it will spit out the file. What it'll spit out is a Postgres byte array, which is the file, and then it will be up to you as the client to save that to the disk or send it to your web client or whatever. It can also spit out a GeoTIFF, so it'll spit out like a georeferenced file and because GeoTIFF is such a flexible format, like any kind of input, we haven't hooked it up to do like arbitrary GDAL output formats, but it feels like that's kind of not really required when we have like fully flexible GeoTIFF and then the two visual formats. If you really want to see someone do something crazy with this, there was a talk at the last PostGIS day that Brian Timoney gave, where he both slurped in the data using an HTTP access from a remote net website, span it through a bunch of filtering and statistical calculations inside the database using sort of standard summary functions, and then vectorized the data, and then finally wrote it all out into a raster, which he then exported as a colorful JPEG. So he went all the way from the web through data processing and out to a final output image using both PostGIS stuff and Postgres stuff and PG raster stuff.
Wow. So it sounds kind of amazing, right? It sounds like there's a ton of functionality. There's even some good reasons why you might want to do it. There's a few different options as to how you can do it. So my next question is, in terms of the language, SQL, is any of this pretty?
Oh, it's exceptionally unpretty. And the reason it's exceptionally unpretty, again, is like the model mismatch, because we like to think about rasters in as large a chunk as possible. People go well beyond like, I've got one big file to like, I have 100 big files, but I like to pretend they're all one object, please. Because they all are, right? They're all just like Landsat. So it seems like not unreasonable to say, just ask your processing system to like, just pretend this is all one thing and give me one unitary process across this one thing. Well, as I've said, to load the data into PostGIS, the first thing you do is to chop it up into really small bits, into these tiny little tiles. And that means that any sort of analytical work that spans an area larger than a tile has to, as step one, gather all the relevant tiles. And if your analysis units are like small, like they're points, then it's really easy because the relevant tile, there's just one. But as your analysis units get larger, building footprints, probably one tile. Neighborhoods, now you have to pull together 4 or 5 regions. Okay, now you pull together 400 or 500. That sort of first step. Step one, gather all the relevant tiles. Step two, merge them all into one working raster. Step three, do the thing you want. You end up with a lot of boilerplate, and it's not necessarily particularly pretty boilerplate depending on the actual processing you're doing.
Whew. Okay, so I guess to try and sort of round off this conversation a little bit now, let's talk about the future. We're moving more and more towards a cloud-native world. We talked about COG just before. We talked about the stack catalog accessing things on the web via these pointers. Do you see this as just like a fun project? Do you see this as something that people should be building upon? Do you see like a real sort of future here in terms of working with rasters in PostGIS?
That's like keep coming back over and over again to the tile structure. And I feel like that is the original sin of the PostGIS raster design. So when I look at like the future of rasters in the database, it's like, first of all, not in the database. So it's more like the question of what is the future of raster access for PostGIS? And as I look at the things which have worked really well, like cloud optimized GeoTIFF and GDAL as an access layer, I think, okay, well, the platonic correct way to do this is to be able to expose rasters to vector processing, mostly like overlay and pull the values out kind of questions, to expose them that way using like a GDAL raster source as the core metaphor for how you access a raster. Because it means that you can get away from having to think about how big tilings are. You can get away to having to think about like where things are stored. You can even like using GDAL tools of things, those virtual raster functionality, you can even like start to treat whole collections of rasters as if they're one raster and yet still have efficient access to smaller parts of them. All the sort of mental complexity of dealing with rasters as they currently sit chunked up into tiles goes away, and that you could still be able to do things like do elevation summaries, do temperature summaries, do the kinds of things which make sense from the point of view of bringing that raster information into the vector world without having to turn into a data management expert. But that would be a bunch of net new code. It would inherit a lot of lessons from the current PostGIS raster, but it would not be the current PostGIS raster.
So I feel like in wrapping up this conversation, I feel like we should offer some sort of definitive answer to people.
Mm-hmm.
So the question is, should you store your rasters in a database?
If your rasters are non-visual, if they are data, and you have questions that involve moving your vectors to those rasters and figuring things out about them, then you should probably consider it, particularly if the questions you're going to be asking are ever shifting, so you're getting some benefit out of the flexibility of the SQL language. Because if it's only one question over and over again, then running up one script to hit the raw files will end up being faster than having it in the database and more efficient and easier to deploy and all sorts of stuff like that. It's really about that sort of got to ask a whole bunch of different questions. I'm never entirely sure what the questions are. Then having it right there at your fingertips inside the database, the value will be higher than the inconvenience.
Paul, if I'm understanding you right, your definitive answer is it depends.
I am a computer programmer, so that is pretty much my answer to any question you will ask me.
Well, I think this is a great place to thank you very much for your time. Thanks for showing up on the podcast again. I really appreciate it. It's always a pleasure talking with you. I know that you have a blog, but there must be some other places people can reach out to you or find out more information about this. Where would those other places be? If you would like to reach out to me, cleverelephant.ca. There's also a blog there, which has some stuff on raster, some stuff on other stuff. I work for Crunchy Data, a Postgres support company. I've been publishing blogs on raster and like doing fun things like connecting to remote rasters and cloud GeoTIFFs on the Crunchy Data blog over the last couple of years. So going there, looking for my entries, you'll see some pretty interesting raster content. The manual at postgis.net is the source for information about how to use rasters in the database, what functions are available, how to use the raster to PGSQL tool. So that'd be the place to go once you're ready to put the rubber to the road. Oh my God, not only was your definitive answer, it depends, but you also suggested that people read the manual. I did. I am the programmer, yes. Unbelievable, but I want to thank you anyway. Really appreciate it. Cheers. Thanks, Daniel. Thank you very much for tuning in all the way to the end. I really hope you enjoyed that episode with Paul Ramsey. I'll have links to his previous episodes on this podcast in the show notes of this episode. I'll also link up some of the more relevant blog posts that he's published around the topic of rasters and databases. I also want to remind you that I've started a new side project. I've launched a job board and you can find it at mapscaping.com/jobs. I'm still working out the kinks, but I hope I can make this into a valuable resource for you in the future. So feel free to check it out. Again, mapscaping.com/jobs. Okay, that's it for this episode. That's it for me. I'll see you again next week. I hope that you take the time to tune in then. Bye.